Okay, suppose we say that the height of an object, a bowling ball, dropped from the top of a building, that the height after t seconds is given by the equation negative 4.9 t squared and plus 29.4 t plus 132.3. Okay, so the first question that we're going to ask is, when did this thing hit the ground? So again, let's think about this. What we're saying is that on the left side here, we're saying h of t represents the height after t seconds. That's what h of t means. Over here, we're saying we have an expression in terms of t that will tell us, when we plug in any value of t, will tell us where at that time, how far off the ground the object is. So clearly when we plug in 0 for t, this term and this term will both go to 0, so we'll end up at a height of 132.3. So that means what we're saying, we'll do a little graph here, that initially we're at a height of 132.3. We go up for a while, and then we come down, and eventually we're going to hit the ground, and we want to know t at that time is equal to what? Now, although it's not part of our actual problem physically, mathematically, we can draw this parabola and have it go backwards until it hits the x-axis at some other value of t, which will have a negative value. And although that doesn't tell us anything about the physical location of the ball, it helps us figure out this important piece of information, which is exactly halfway between those two values will be the t value when the object is at its maximum height. Okay, so here's what we do. We're going to factor out, we're going to first set this equal to 0 to first answer the question, when does this hit the ground? Or in other words, when is its height off the ground equal to 0? Okay, we're going to factor out negative 4.9, which is going to leave us with t squared minus 6t minus 27. Okay, can we factor this? Yes, we can say, by the way, we can divide both sides by negative 4.9, so we get 0 is equal to t squared minus 6t minus 27, and that can be factored to t minus 9 times t plus 3. What that means is that the object is going to have a height of 0 at t is equal to 9, t is equal to negative 3. Well, we reject the negative 3. It doesn't make sense in this problem, but it will help us, as I noted before, with finding the maximum value. So at t is equal to 9, we have it hits the ground. At t is equal to negative 3, we know that's our other x-intercept for this equation here. Okay, so we now know when it's going to hit the ground, which is at t is equal to 9. Oops, equals 9. Halfway between 9 and negative 3, we add those two together and average them. Negative 3 plus 9 is 6. Divided by 2 is t is equal to 3. So that means that this object is going to be at its maximum height at t is equal to 3. And now we just need to plug our 3 into the equation up here to get the height that this object will be at t is equal to 3. It will certainly be above 132.3. Okay, so we have negative 4.9 times 3 squared plus 29.4 times 3 plus 132.3. So this gives us negative 44.1 here plus 88.2 plus 132.3, and that ends up equaling 176.4. So our height off the ground at t is equal to 3 is 176.4. Okay, so that's how we do this problem. So just as a recap, we want to set the equation equal to 0 to find out when it hits the ground. We want to find its highest point to find the maximum height. The highest point is always going to come between the two values that set our equation equal to 0. Again, and that's because this parabola is so symmetrical that these two values are going to tell us exactly, halfway between them, tell us exactly what the x value is for this highest point. Okay, we're done.